Caranya caranya
and force a reload, this app looks the way it did before, because of course we haven't added any new UI elements, but the fact that it looks like before and we don't have an error here shows us that outsourcing this code into a custom widget worked. And this was a crucial step because you will work with custom widgets all the time when working with Dart and Flutter. You will see it all the time in this course, and you will need this feature all the time in your own projects. So we added our own custom widget. Now before we continue, there are two things I want to do with that. For one, we got these blue squiggly lines. And the question is, where's that coming from? Well, if we hover over it, we see that constructors for public widgets should have a named key parameter. So what's that about? In the end, your own widget classes, so classes that extend stateless widget or some other class, which you'll see later, should have a constructor function added to them. I mentioned that typically you don't need to add one, you get one automatically, but if you want to add some extra settings or some extra configuration at the point of time this widget is created, you have to add your own any new UI elements, but the fact that it looks like before and we don't have an error here shows constructor function. And adding a constructor function is quite straightforward. You simply repeat the name of your class, so in my case gradient container, and add opening and closing parentheses thereafter. Now you could add opening and closing curly braces, so you add this like a method just without a return value, but other than that you add it like a method. And then here you could do some initialization work. This, by the way, is a comment which can be added with 2 forward slashes and which allows you to add some comment text which will not be interpreted as code, but which will be ignored, but which can help other developers understand your code. So this is how you could add a constructor and do some initialization work, though often you won't even need to add these curly braces. Instead here, to get rid of these blue squiggly lines, you just have to accept a special named parameter as part of your gradient container. And you do that by adding opening and closing curly braces. This is how in any function you can accept named arguments. Positional arguments are accepted by simply adding a comma-separated list of parameters. Named arguments or parameters are accepted by using curly braces around that list. And then here, for example, A and B would be the names of the arguments you want to accept. But here it's a special argument named key which you should accept. And this key argument in the end needs to be forwarded to stateless widget. So this widget from which we are inheriting, which we are extending, wants a key argument. And that's why your class should accept such a key argument as well and forward it to stateless widget. Now to forward it, you have two main options. You can add a colon after your constructor function name and the parentheses. And then thereafter, you can do some variable initialization work, which sounds strange, also because we haven't learned a lot about variables yet. But here you can reach out to the parent class from which you are inheriting by using another special keyword built into Dart, the super keyword, executed like a function. Effectively, this is calling the constructor function of the parent class then. And here you must set the named key argument to your key here, which is why I'm repeating key. This key here is referring to my named argument called key. The first key in front of the colon is referring to a named argument called key in the super class, in the stateless widget class. This would be one way of forwarding this key argument, which is what you should do here. But since you need to do this quite often, basically for all your widget classes, and this is a bit verbose if you write it like this, Dart also gives you a shortcut. You can simply write super.key here, and this will accept a named argument called key and automatically forward it to the super class, so to stateless widget, under that same name, so also under the name key. And that is something you should do here. Now I also got some more blue squiggly lines here, where in the end I learned that I should turn this into a const constructor by adding const in front of it. And this is a place where we haven't used const before. We only used it in front of values. But in the end, when we used it in front of values, we took advantage of constructor functions that had this const annotation internally. When defining your own classes with your own constructor functions, you often can add const in front of them to tell Dart that this in the end is a class that can be optimized, that can be stored in memory such that it is reused, as I explained a couple of lectures ago in this section already. So with const in front of your constructor function, you basically unlock that const is then used in front of your class when it's used as a value. So because of const added here, we can also add const here, or since scaffold and material app actually also are defined to be optimizable with const, you can even add const here in front of material app. Using that optimization technique I mentioned before in the course, now here just also with your class unlocked to be optimizable. And as always, the code editor will simply tell you when you have an opportunity to unlock such optimizations. In this case, by telling us that we should add const here, which is why I'm doing that. So that was one thing I wanted to take a look at, constructor functions, which is a feature we'll later also use for other purposes, but which we here needed to add to make sure that this value, which is wanted by the parent class, is forwarded correctly and to unlock this potential optimization. Now, besides constructor functions, the other thing you should be aware of when working with classes is that it's considered a good practice to put them into a separate file. So here we can select this entire class and cut it, and then in the lib folder add a new file, which I'll name gradient_container.dart. And the name is generally up to you, but it should follow this naming pattern: all lowercase, multiple words separated by underscores. Dashes are technically allowed, but will actually not work, and this would be quite unreadable, so underscores it is. And then in this file, you can store your class. And we do this, we split the code across multiple files to keep every file readable and maintainable, so that all these files are relatively lean and don't contain endless amounts of code, but you instead just have one main thing per file, one main function or collection of functions, or one main class per file. Now, of course, with that added to a separate file, we got a bunch of errors in here because all these Flutter specific types and widgets are now unknown. They are unknown because the import to the Flutter package is only here in the main.dart file. But this must be added to every file where you are using features from that package, which is why you should copy it and add that same import here in the gradient_container.dart file. And with that, all these errors go away. We still have an error in the main.dart file though, because gradient container is unknown here. This is not defined here, because it is now defined in a different file. And Dart does not automatically scan and connect all your files in your project. Instead, you have to explicitly define any connections between files that you want to consider. And you do this with the import keyword. So here in main.dart, besides importing something from the Flutter material Dart file, we also must add another import where we also import from a package, but this package is now our own project. And therefore, after package : we use our project name, in my case, basics. So here I'll use basics. This is basically whichever name you gave your project when you created it with Flutter create. So it might also be first app if you're still working in that project. Here for me, it's basics. And then here, it's the gradient_container.dart file from which I want to import. And you should, of course, again, get some suggestions here, also regarding your project name. You can always open those suggestions with Control-space. And then here, if I import from gradient_container.dart and add my semicolon, gradient container is found again. And hence, if I save everything and reload, it still works. There is no error because we again have some valid code here, now following common best. Styled text as explained in the last lectures, and after a short pause, which I give you to pause this video and try this on your own, we'll outsource this into a custom widget together. Give you to pause this video and try this on your own, we'll outsource this into a custom widget together. Do this on your own. Create that custom widget for this styled text as explained in the last lectures, and after a short pause, which I give you to pause this video and try this on your own, we'll outsource this into a custom widget together. This into a custom widget together. Video and try this on your own, we'll outsource this into a custom widget. Video and try this on your own, we'll outsource this into a custom widget together.
It's just two context with another text.
Did you succeed? Let's now do this together. For that, I'll first of all create a new file, because you learned that you should put your own widgets into separate files in that lib folder. And I'll name it styled_text, because I will add a styled text widget in there. Styled text.dart it is, therefore. And then in there, we create a class, and I'll name it styled text. The name is up to you, but it should follow these conventions about which you learned. And we of course extend stateless widget here. Though for this to work, you also must add the import to package flutter material.dart as you learned. Now with that set up, we must add that build method by adding override and then widget build, accepting this context parameter and returning a widget as you learned. And the widget that should be returned here should of course be this text here. So we can cut this from gradient container and return this here instead of styled text. Now here I got a bunch of blue squiggly lines because indeed here we can now add const again, as you learned if you hover over these blue squiggly lines, since this can be cached. This is, by the way, independent from the fact whether we add a const constructor to this widget or not. This optimization in this widget tree is detached from the fact if we unlock this widget for being optimized itself. But of course here we should add a constructor for the same reason as before, to forward that key argument about which you learned. Hence I create a constructor by repeating that name of the class, and then here opening and closing curly braces to accept an argument named key, and with super.key we then forward this to stateless widget. And here we should now also add const, since this is suggested to us here to unlock various optimizations by Dart. And with that, we have our styled text widget defined. We can now use it in gradient container. There we can type styled text and use it like this. But of course, to unlock it here, we also must add an import in the gradient container.dart file. Here we must import from our own package, in my case named basics, in your case maybe named first app, or anything else, whatever you named your project. And then here I want to import from the styled text.dart file. With that, with this import added, this styled text widget down here is found. So this here works. And if I save everything and force a reload, my application still works. And this was a nice practice for creating your own widgets. So we learned about custom widgets, a super important feature you're going to use all the time when working with Flutter. Now there's one thing you can do with custom widgets that makes them even more powerful. But before we can explore that thing, and before we then thereafter can come back to this app and add more features to that, we have to dive into variables. So what are variables? Variables are data containers, and this feature exists in basically all programming languages, because it turns out that in all programming languages you're working a lot with values, like also here, where in our styled text we have some text, or basically everywhere else we have a bunch of widgets and configuration objects, which are of course also all values. Now to understand variables, let me go back to the gradient container here. And here we could say that maybe these alignments, which of course also are values, should not be stored here in this part of the code, which is hidden quite a bit inside of the widget tree, but maybe we want to define them up here at the beginning of the file, so that if we ever want to change these alignments, we can do it right here at the top of the file without having to dive into our widget tree. This is of course just a convenience thing in the end, but the more complex your code and project gets, the more little tweaks like this could help. To do this, we could cut the value from down there and instead store it in such a variable, because variables, as you learned, are data containers. In Dart, they are created with help of the var keyword, then the equal sign operator, the so-called assignment operator, and then the value that should be stored, for example, a string. So here, if I want to store this alignment value, I could create a variable here outside of my class. We can also create it inside of the class, but for the moment, let's do it outside. Then give it any name of your choice, like for example, start alignment. The name is up to you, but just as before with other names, it should not be separated into multiple words. Instead, words inside of words should start with an uppercase character. But unlike class names, the overall variable name should start with a lowercase character, so it should follow this naming pattern, and the name should describe which kind of value will be stored in that data container, in that variable. And then we assign the value with an equal sign, in this case alignment top left, for example. So that's how we could define a variable. We could then add a second variable, and that is this end variable. So therefore, I'll name this one end alignment and store alignment bottom right in there. And with those two variables added, we could use them down there to assign start alignment as a value to begin, and here end alignment as a value to end. Though here you will notice that I'm now getting an error, that a value of type null can't be assigned to a parameter of type alignment geometry. This is a bit cryptic to understand though. What does it mean? Well, variables, when created with the var keyword, which we're doing here, can actually be reassigned. Here I'm assigning an initial value, but I could then change that value. For example, here in the build method. Here I could set start alignment to alignment.center. That's a core mechanism of variables created with var. You can reassign them. Now that's in the end where this error is coming from. This null part can be confusing, but it actually also tells us that the const keyword seems to be the problem, that we might want to remove this const keyword. And here it's referring to this const keyword in front of box decoration, since if we add const here, it's also implicitly added to linear gradient, and that is the object that takes begin and end. Since the values of these variables could be changed, it's not guaranteed to be stable, it's not guaranteed to be constant. And that's exactly the kind of problem we're facing here if we do have const in front of linear gradient or box decoration. We can't tell Dart that it can cache and reuse that value because actually these variables are not locked in. They could change potentially, and therefore reusing this value would be unsafe because Dart might accidentally reuse an outdated value, which is why you can't use const here then. You could add it in front of this list still, since these colors are indeed locked in place here and hard-coded here. But that's the idea behind variables. We simply have data containers that store values, and we can define them once and then use them multiple times wherever we want later in our code, as long as that code has access to the variable, which here in this case is the case. Now variable So we learned about custom widgets, a super important feature you're going to use all the time when we're. Now variables actually also have types. Here I'm creating two variables, and in this case here, Dart is able to infer their types. If you hover over your variable names, you see the type here, and Dart knows which type will be stored in this variable because it simply takes a look at the value you're initially assigning to the variable and uses that value's type, in this case here alignment, as a type for the variable. If you would not assign a value initially here, and you instead would only set one at a later point of time, like this for example, the inferred type would be dynamic, which is a special type in Dart that in the end just means that Dart knows nothing about the type of this variable and it will indeed accept all value types. Typically, you want to avoid this because that can lead to bugs in your application, because without type information, Dart can't ensure that you're not accidentally using the wrong type in the wrong place. And therefore, in such cases where you don't assign a value initially, you should replace the var keyword with the name of the type that will be stored in that variable. Here, for example, alignment. With that, Dart would have more type information, though of course here we would still get an error because we tell Dart that we want to store a value of type alignment in this variable, but initially we store no value in here. We would have to add a question mark after alignment to make it clear that start alignment is either of type alignment or null, so that it's basically optional whether it's set or not. So a null value would be allowed here. Now this would lead to more errors down here because begin actually doesn't want a null value, and therefore I'll get rid of that and just initialize it as I did it before, all in one step. But it is important to know about this alternative syntax where you do explicitly set a type and not rely on type inference if you're not initializing the variable with a value. If you do that, as we're doing it here, using the var keyword is recommended, because here you should indeed rely on Dart's type inference. Now variables Now, variables actually also have types. Looks that in the end can lead to bug you're not willing in the past, whether it's set or not. Or down here, because I just initialize it as I did it before. Therefore, I'll get rid of that and just initialize it as I did. Now, there is more you should know about variables. For example, you sometimes have variables that never change. Of course, technically, it's called variables because the value is variable. But in the end, it's all about having data containers. And those data containers could also be set once and never change thereafter. For example, here, I never assign new values to start and end alignment. And if you know that this is the case, it's recommended that you use final instead of var. Final is another built-in keyword, which simply means that this data container will never receive a new value. And whilst you could of course stick to var, it's always a good practice to be as restrictive as possible so that you never accidentally reassign a value here. Of course, you're the only one working on this project here probably, but in bigger teams with multiple developers working on the code, you want to be as restrictive as possible to make sure that some colleague of you is not accidentally overriding one of your variable values somewhere else in the overall project code. That's why the final keyword exists. Now here I'm of course getting some blue squiggly lines that I should use const instead of final in the end. And indeed, that's another usage of const which we haven't seen up to this point. You can create so-called constant variables or constant data containers, you could say. It's almost the same as final because const also makes sure that you can't reassign those variables, but unlike final, it provides some extra information to Dart. When using const here in front of a variable name, so on the left side of the equal sign in the end, you're telling Dart that the value that's stored in here is a so-called compile time constant, which means it's simply locked in at the point of time this code is compiled. Now that's not necessarily always the case. You could, for example, also have some code where you're maybe calling a function, getAlignment, which doesn't exist in this project, but which could exist, and which then behind the scenes could dynamically calculate the desired alignment. You could definitely have something like this in your application, and if that's the case, that of course means that this function must be executed when the app runs to get the actual alignment value. In that case, it might still be final. You don't reassign the variable thereafter, but it's not compile time constant because the value that might be returned by getAlignment is not known at the point of time when this code is compiled yet. Instead, it's only known once the code executed. And here that's different for alignment top left. This indeed is locked in at the point of time this code is compiled. Top left is clearly defined to the top left corner of the device, so to certain x and y coordinate values, and therefore you can use const to tell Dart that this is not dynamically derived at runtime, but can be locked in and set at compilation time. And this is another potential performance improvement because if some value can be locked in at the point of time the code is compiled, this code doesn't have to execute when the app executes. Instead, this locked in and internally saved value can be used by Dart when this code is about to execute. So it's some internal performance optimization, and therefore here, when defining variables, you should also use const instead of final whenever it makes sense. So whenever you have such a compile time constant value. And just as before, the code editor will simply tell you when you have such an opportunity. By the way, with that set to const, you can also re-add const down there in front of box decoration, because now that this is const instead of var, you guarantee that it will never be reassigned, And therefore you can use const here because this code is now no longer potentially variable because it can't be set in any other place. It can only be set once, and therefore here we can unlock this potential optimization of the box decoration object again. And in case this is all not 100% clear just yet, you will see variables and final values and constants over and over again throughout this course. But it is important to be aware of these concepts right now already because we'll use more variables in the next lectures.